Others can continue if anyone wants to introduce themselves. Meanwhile, when all join, we'll start with the session.
Hello everyone, I'm audible.
Yes. Yeah, you are audible.
My name is Manvi and I have completed my graduation in 2023. I am currently undergoing training, but due to personal reason I came back home. I have good knowledge up to SystemVerilog.
Okay.
I haven't attended UVM classes, so I don't know this actually.
Okay, okay.
Hello.
Yes.
Yeah, can you please elaborate more on the project side, like what project we are doing in this workshop?
We will be doing the APB protocol.
Okay, like we are creating the verification
Yeah,
like
yeah.
component from scratch, right?
Yes, correct.
Okay, got it. Thanks.
Yeah. Anyone else have any other queries can ask me. Meanwhile, we are waiting for others to join.
Yeah, like I have one more query. Is it
Yes, yes.
yeah, I mean, is it like parallelly we need to code ourselves as like how
We will see like if it is possible to do it in the session itself, or I'll give an overview. We will see how we will do it. So first we will try to make a skeletal with no errors, and then if possible I'll give some time for one day or within the next session if you guys can do it like that. We'll plan accordingly. Okay,
okay.
based on the
So
timing constraints. But I'll make sure that everyone is able to get how the entire structure is done, how the skeletal from the line one, how do we start coding, how do we fetch the features of from the specification. So all those, I'll make sure that it happens.
okay. So like for all the concepts you're providing the codes, right? I mean
Yeah,
to
yeah.
work it as
Yes,
system.
yes. Correct, correct.
Then fine. Yeah, thanks.
Yeah, yeah,
Yeah, I have one doubt on
yeah.
what tool we will be working.
EDA playground.
EDA playground. Okay.
Yeah, yeah. We'll wait for 2 more minutes and we'll start. Okay, guys, so let's start with our session today. So I'm so happy that so many people are using this opportunity, like getting the UVM workshop with means in the day wise we have planned, right? I am also very excited like you guys to know how this workshop goes. But I have one suggestion for every one of you is that just make the session interactive when things are asked. That's okay if you go wrong or that's fine, but just let us make the session interactive. Because of that, many things will get clear with from the other side. Means the one who is not asking their doubts also, they will get more information from me. That's why let's make the session interactive. So, as we have already shared you the plan of the day wise for the UVM workshop, right? So, for the first day, it's little, let us make it a little short. So, it's like basically the introduction on the UVM, why we have UVM, and what are the major benefits of the UVM, like why we are choosing on SystemVerilog. Even in the SystemVerilog, using SystemVerilog, we can create a test bench, right? But why the UVM has come into the picture, what makes it more reusable, and what are the different features of UVM we have. So all this we will discuss, and we will have a small overview of the test bench architecture, not the entire thing. And tomorrow we will discuss the test bench architecture and in detail of the things. Okay. So today there won't be much related to any the coding session, but you will get the actual thing what are there in the UVM. Okay, so the first we will start with the UVM evolution, like the UVM how it has come into the picture. All these things I have make a note of the evolution of the UVM. So before that, I would like to know from anyone, do you guys know anything about UVM? Any small intro kind? In very few lines, can anyone brief me out? What is UVM exactly? Is it a language or is it a methodology or what is it? So it's used by the design engineer or it's used by the verification engineer? Anyone?
Hello.
Yes.
UVM is a methodology. It's basically used for verification industry.
Okay. Okay. So it's used by the design engineer or the verification engineer?
Verification engineer.
Yeah, correct. So basically, you guys can just go through this, like what is the evolution of UVM. There is nothing much to explain here. This is just like to have some knowledge. It's good. The main thing what I can say is the UVM is nothing but the universal verification methodology. So the name itself, it says that it is universal. So it means that we are trying to make the things which are common for everyone so that we are making it for more reusable. Okay, so that is all. Here it is given like what is the evolution of the UVM and from where exactly it has been started, and this by the Accelera verification IP, all these things information I have put, you just can go through. Anyone have anything to say, or otherwise everyone mute yourself? Okay. Guys, please mute everyone. It's quite disturbing. Okay. So in UVM, basically, as we have already discussed, it is a standard verification methodology, and this as there are more use cases than SystemVerilog, we are making the UVM like as a verification methodology. It is has modularity. There are so many other features which is making it is making it popular, and it is letting others to use this UVM methodology. That's why most of the industries have migrated to the UVM methodology. Some are still not migrated to the UVM, but most of the people have migrated to the UVM methodology. So anyone know what is like a test bench in the UVM or in any in verification? What is a test bench basically?
Hello.
Yes.
Test bench is a non-synthesizable code.
Yeah.
It used to verify the module whether it has any whether it has timing constraints or right or wrong.
Yeah. And anyone else? Okay, fine. So let me tell in a simple way, like for example, you have written one design, whether it could be Verilog, SystemVerilog UVM, keep that aside. But for everything, we have a test bench, right? What exactly this test bench is basically works is how well our design has exercised the features, means how our design is responding to the different stimulus which we are giving. So based on that, we will we know the design we have designed for particular specification and all. So from the test bench, what we will do is we will provide a desired stimulus to the from the test bench, and we will try to check the desired outputs. Based on the design, the output should be evaluated. So through test bench, we give the stimulus. So we will write a design, and then the design is instantiated inside the test bench, and then we give the proper stimulus, and then we will also try to observe those things in the waveforms, and or otherwise we will give some display statements, and we will try to observe what is the given inputs and what is the desired output. So based on our design, the output is generating properly or not. So these are nothing but the test bench main. So this is the main motto of the test bench, right? So like that in the UVM, it also has, so basically why UVM has its more importance is that in the UVM, we have different base classes available already. So we are using those classes and we are trying to get, so anyone know what is inheritance?
Yeah, so basically we are extending one class from another class. So
Yes.
yeah, that's what, like, it's very high abstract, but
Yes, yes. That's fine. The basic, what is the inheritance means we are trying to derive one class from the other class. So the class from which we are deriving is called the base class, and the class which we have derived is called the derived class. So UVM has a library. Here we are telling, right, the UVM has a comes with a library of classes. So it means that the UVM has the different classes already, which are called as a base classes for us, because we are trying to derive a class from that particular classes, right? So that will be a base class or parent class, whatever you call it as, and we will be having a derived class. So whatever methods, whatever things we have in the base classes, we can use it, right? Using those, we will try to create our own test bench environment. So in our test bench, we have different components. So for each component, we have a base class. So we derive our class with that particular base class, and then we will try our whatever protocol specific behavior is there, that we will include inside that. Okay. So I have highlighted something called what is constraint random test benches. So we have heard that what is a test bench. Then what is about the constraint random test bench? Let me give one small example. If we will see through the code later, but now let us have just a gist of it, like how exactly the random constraint random test bench works. So anyone know what is randomization in the SystemVerilog or in the verification?
Hello.
Yes.
Yeah, ma'am. In randomization, we are giving random input patterns within the range.
Okay. So what you are trying to achieve through that basically?
So, in by using randomization, we will be giving number of inputs for testing our design.
Yeah, correct. So basically, whatever, as I said, right, from the test bench, we are trying to provide the stimulus, basically different kinds of inputs you are providing. So the project is in the real time, it's not that simple as we think, like a simple adder or subtractor or some marks. These are the simple things which we work for to learn the concepts. But in the real time, the projects are very complex, right? So in that case, how the stimulus get generated? Will you sit and write each and every stimulus by your own? It's not possible, right? Then this randomization comes into the picture, where we'll have in the randomization, we will have some stimulus, whatever variables or the input ports we will be declaring in one of the transaction class, and inside the transaction class we will be taking some variables. So the inputs can be randomized, so we can declare like a rand of that particular input. For example, I have taken some enum in the config file, or any of the file I have it, or in any of the test or enums package, I can create one package file where I can have the different enums, okay? And suppose my enum name is like this, okay? Bus speed E. This is my enum name, and in that enum I have different bus speeds like standard speed, all that. So now in the transaction class, what I will do is I will randomize that particular enum. Okay, saying that like this. So this will be there inside my transaction class. If you don't understand this, don't worry. This is just to know what is constraint random test bench. But when we go inside to the code and all, everyone will get to know. So don't worry if you don't understand this for right now. So here I have created a random variable, right? So this bus speed will be randomized. So for suppose the bus speed has something like three things inside that: standard, fast, and fast speed plus, something like that. There are three speeds, three different speeds. So when I randomize this, I have not provided any constraint to it. So it means that each and every time I run that particular test case, and inside the test case I will give the bus speed, I will not provide any bus speed through any constraint. It means that what it will do, this bus speed will be randomized between standard, fast, and fast plus, okay, or fast speed, whatever it is. So if I want to make sure that I want to have by default, if anyone doesn't provide anything, then I can write something like soft constraint, the bus speed. See, this is the constraint name basically. Then I have something. Now this is the enum handle, right? So this will be our handle name. So I will take like bus speed is equal to the standard. So actually, when we are giving the value to the bus speed using constraint, we have to take this double equals. That is nothing but an assignment here. Okay. So likewise, we will do. This will be there in the config file itself. Means the common things where we have there, or even in the transaction class also we can have it. There is no issue. And so when I have provided like this, what is soft? So didn't anyone get doubt why we have used soft? This means that we can override this particular constraint. So now in the particular test case, now this is my test file, okay? Inside this test file, I can, if I'm not providing anything, then it is like it will be standard. Or if I want to provide anything, then with particular this transaction class, everything we will take, and we will give like the bus speed should be equal to whatever thing which you want, like either fast or fast speed. So basically, this is what means like constraint random test bench. First, initially you have randomized that particular variable, and then later you have constrained it. So what is the advantage of this? Like, why should we take this way? Can anyone explain? What could be the advantage of randomizing it and then constraining it? How will it help us?
So like suppose say like we have like 100 futures to test.
Yes.
So with the randomization, maybe we can achieve like maybe 70-80% of the normal test cases we can achieve. Through
Yes.
constraining, we can make like directed test cases.
Yes, correct. So what he's trying to say is through randomization, suppose 60% of things are covered. So what are left out are nothing but the corner cases, right? Which it is not able to. Like first step, what we will do is when we randomize, we will increase the count. Means for example, we will run the same test case for 50 count or 60 count, okay? And then we will see that some possibilities will be covered by it, but there will be some cases will be still left out. So those things we have to cover through the corner means directed test cases, so that you can give the constraint or something in the particular. You can write one more test case where you want to check like only these things are covered, this is not covered, then you will write a directed test case. Like that, there are different kinds of test benches. So so that's why I have highlighted this, because this is one of the important thing which we should know, like in the constraint tandem test benches, which will be supported by the UVM. That's why we have mentioned this. Okay. So far, any queries, anyone? Okay. So as we have already discussed, like we have SystemVerilog. Then what are the limitations which we had in there, and what are the extra things we have it here in the UVM? So development of the test cases is easy even in the SystemVerilog and Verilog, but we don't have the plug and play like in the like how we have it in the UVM. In the same way, the Verilog and SystemVerilog, we don't have that plug and play feature. So what do you mean by the plug and play feature? Anyone?
Plug and play means reusability of the test bench.
Yeah.
So if we have multiple test cases, so we don't have to change the environment every time we are checking a feature. Only the child test case we can change, and rest of the environment is same.
Yeah, we can use the sequence which we have provided here in the some other project also, right? We can reuse that. For suppose we have developed at the subsystem level, the same sequence can be reused at the some other SOC level. Means in the some other complex projects also, the same sequence can be reused. That is because here we have the modularity. Modularity is mean, what do you mean by module? Like how for the entire UVM workshop, we have created some 15 modules, right? Means day 1, day 2, day 3, day 4, day 5. So we have made some separations for each of them. So there is no dependency with each module to the other module. So when we have structured our things in that way, we can make sure that we can reuse that particular module, or we can reuse that particular sequence in somewhere else also. That is the main thing which is there in UVM, which was not available in the Verilog and Verilog. So there are some more features like in the UVM, you can just alter the things from the top level, and then you can make sure that you are trying to fetch the different kind of the driver, which you, for suppose we are using some driver in the flow, but you can change that driver using some UVM factory methods and all. You can just override with some other driver also. So with that, you need not change the entire flow of it, just the particular thing which you want to change, that you can do it. So all these capabilities are there for the UVM. That's why it is which are not there in the SystemVerilog and Verilog. The HVL languages means the hardware verification language, which are like a Verilog. In there we didn't have all this. So where the UVM provides us all this. And then if we think like what is verbosity? Anyone know what is verbosity?
Verbosity is like we can use from top level. So UVM low, UVM medium is there. So whatever display statements we want the test bench to print, that we can pass from the top or the command line. Then only we can see those print statements only, instead of every print statement. So that will make a log file so less bulky.
Correct. Good. So basically what verbosity means, like we will be having the dollar display statements, right? In the Verilog, SystemVerilog, everywhere. Likewise, in the UVM, we can also use dollar display, but it is more preferable to use UVM infos, okay? Like dollar display only, we have something like UVM info. So whatever UVM info is nothing but whatever you want to print in the log file, those things will be there in the UVM info. For example, we are started the coding of driver. So you can write in the UVM info like driver coding started. Like that we do, right? So to debug it. So to find out like whether the processes are coming till driver or before that only things are struck, or what is it. So to find out all those only we have the different verbosity, all that. So in this verbosity, what it means, like as I said, from the command line argument we can provide any one of the verbosity level, but the by default, if you don't provide anything, the by default verbosity will be UVM medium. Okay, so what is the by default verbosity?
Yeah. Yeah, UVM medium.
UVM medium.
Yeah,
Okay.
we have different verbosity levels actually. UVM medium, UVM low, UVM none, UVM high, everything. We will discuss them in future little more in detail. But just now, get to know that UVM provides us a control to to control the different display statement that will be printed in the log that can be controlled by you. So at very starting level you are, then you can give the different verbosity level so that all the statements has to be printed because it will help you to debug. Then you have achieved to some more level. So then you will change one verbosity. Like that you will keep on changing the verbosity level, and at the end you will, with the end time of the project, means most of the things you have already resolved and you are trying to send this to the sign off. Then you will change the different verbosity level, and if sometimes you want to debug any failure from the regression, you got that the test is failed. So from there you will collect the seed value and you will run the test case. Then what you have to see, will you try with the different, you have to use the verbosity level where it will print most of the printing statements, right? So you will choose such a appropriate verbosity level, and then you will run that particular test case to observe more information, and then based on the information again you will just correct those, and then you will do that. So this is a process we will do to debug our test cases and make sure that our test bench is verified properly. Okay, and then we have something like config db. At this time it's very quick, early to explain you guys what is config db. We will go it in further itself because it might be confusing for some people. Okay, and then this is basically the same. This is nothing but the same thing. Okay, so there are some acronyms which we will be using further. So it's better you guys go through this, because when someone is telling what is DUT, you might know what is DUT. DUT is nothing but, it's not device under test, it's a design under test. Okay. You guys just corrected. This is design under test, not device under test. It was by mistake. So the UVM is UVM, you all know, right? The universal verification methodology. CDV is nothing but the coverage driven verification. We will discuss about this also, what is coverage driven verification further. And DUT means the design under test, the particular design which you are verifying, right, under your test bench. So whatever stimulus you will be providing from the driver to the DUT through the interface, and you will collect the output from the DUT to the monitor. So all these on what design we are exercising, no, that design is nothing but the design under test. EDA is basically the electronic design automation. Means now someone at the initial stage they have told, right, I have worked on Questa Sim, I have worked on Mentor Graphics. So these are nothing but the EDA tools. Different projects and different companies use different EDA tools. So and that's fine. In whatever EDA tool, people will be asking, like, I have the experience of only this EDA tool. Is it okay? That's totally fine. If you are well versed with one of the EDA tool, it's enough, because other things will be, most of the things will be just self-explanatory for us. So we can, it will be tough initially, but later on, while on practicing, it will be easier itself. So there is nothing to worry more about which EDA tool you have worked on or something. Okay. And HDL means hardware description language. These all you guys will be knowing. So what is the thing which we have to discuss is the VIP. So anyone know what is VIP?
Yes, like yeah, it's not like synthesizable, but if someone wants to test their design like
Okay.
IP, they will just connect their IP to VIP, and VIP will send the stimulus and get the responses from DUT, and we can like analyze.
Yeah. Anyone else?
So VIP is like, suppose we have a protocol. So suppose I2C protocol is same in most of the companies they are using. So suppose some company wants to check or verify the I2C protocol, then they will get the complete verification environment of that I2C protocol. That will be a VIP. So they will just connect or instantiate the DUT to that VIP and provide the stimulus from the top. They won't have any access to the internal components. Only the top level structure, top level components they will access to give the stimulus.
Correct,
That
correct.
is the way.
Basically, it will be just like a black box for you. Only the interface you will be able to see. The other things you will not be able to see. So otherwise, you can also understand like this. For example, you are trying to verify the I2C block or the IP only. So you will get you will get some VIP from the Synopsys VIP from I2C itself. Synopsys VIP you have got it. So how you will connect your IP to the VIP. And how will you verify that whether your design is working properly? Is like how you can do is, for example, your design has different things, like the I2C can act as master, I2C can act as slave, and the I2C can act as master transmitter and master receiver, slave transmitter, slave receiver. There are so many possibilities. So what you can do is, in the VIP side also you will be having some sequences, and the design side also you will be having some sequences. So in one of the test case, what you can do is your VIP, which is there, that you can configure it as slave, and your design you can configure it as master. So when this both are connected and we are trying to write a test bench, then this master, which is acting as the design, which is acting as a master, and VIP, which is acting as a slave. So the master will send the data, and the VIP is acting as a slave, right? So it will respond to it. So for example, I2C, what will be the I2C will be doing? It will be generating the clock. It will be generating the start condition, everything. So what slave will do? It has to send the, when the master has sent the address data, then slave has to acknowledge it to the master, right? So that will be given from the VIP side. So when everything is getting proper and at the finally we are getting the data, we will do a comparison between the actual data and the expected data, and then we will make sure that okay, my design is working fine. So why do we need to take the VIP itself? Because see, if both the testing side and what your design side both are in the immature stage, then how will you make sure that where is the issue coming from? So the verification IP is already verified. Most of the things are already verified. It is assumed that there are very few things, maybe it could be some issues. When there is an issue, we have to report to that particular Synopsys. So for example, we are using Synopsys VIP, we have to report to them like this is what is happening. So they will tell us what all configurations we have to do. So we have to recheck what all configurations we have done. If we have done according to the norms, and even then we are facing the issue, then we can tell them. Then if there is any issue from their side, they will recorrect it, or they will give us some more. They will also work with us, like what are the things which in the simulation is happening, everything, and based on that we can come to a conclusion. So basically that is verified, right? So on the verified thing, you are using your design and trying to give the data and trying to collect the responses. So you are making sure that your design is working fine. So basically, the end motto is to verify our design, right? So there are different ways that we use. Okay. So far, is it clear for everyone? Are you guys able to follow?
Yes.
So this session we can use such way that's so that if you have any feedback, you guys can give me, so that we will put our entire workshop in that pace. Okay. So that's why when I'm asking like if is it okay, just tell whatever is there. Okay. Fine. So we have already discussed like why we have the UVM. We said that in UVM there are so many base classes. We have different components for in our testbench architecture. So for all those components, we have the base classes. This is all we have already discussed, right? That's what is there over here. Like in the major features of UVM, that is like we will be having a base class library. So we have something like UVM component here and UVM object here. Okay, UVM component is nothing but which is there inside the hierarchy, and the UVM object is not belonging to the hierarchy, and it will be outside the hierarchy. Means the UVM component means which will be there for the entire simulation, but whereas UVM object is not such. So all these things we will understand further in detail, but just whenever I get time, I will just try to put some information, so that the more times it gets repeated, the more it will get registered to you, right? So we have different base classes, like for example, we have driver, monitor, like that, right? So all those are the components. So those components will be extended from the UVM driver class, or the UVM. If there is a driver, it will be extending from UVM driver. If it's a monitor class, it will be extending from UVM monitor. If it is a transaction class, it will be extending from UVM sequence item. And if it is a coverage class, it will be extending from UVM subscriber. And if it is a scoreboard class, it will be extending from UVM scoreboard. So whatever class, whatever component you are using, that will be extended from its particular base class. Is it clear for everyone? Hello.
Yes, ma'am.
Yeah. So can anyone say, like, we have something called mailbox, right, in the SystemVerilog?
Yes.
So we are saying that we have different components in our test bench architectures. How each component will communicate with other? Yeah, do you have any idea, anyone?
So there are ports in this case. In UVM, we have TLM ports and analysis ports and all those things. So
Yeah.
in SP, we have in mailbox, and in UVM, we have ports.
Yes, correct. So SP, we already have mailbox, which is connecting between the different components, which is trying to, this is basically helping the inter-process communication. Inter-process communication is nothing but there are two different multiple processes which are there in our system. Each process is trying to communicate with the other process through some mechanism, right? So here it is nothing but the TLM. It is using the TLM, that is transaction. Why it is TLM? Because it is transaction level modeling. It means whatever data which we are transferring from one component to the other component is through your transaction itself, right? So whatever transaction item is getting transferred. So that's why it is called as transaction level modeling. In that there are different kinds of ports. There is something called TLM ports, and then TLM expose, the implementation ports, and TLM FIFO, and something like analysis ports. We will cover this in I think day 3, I guess. There we will cover about this TLM ports. And I have already mentioned we have something like config DB. We will discuss it later. And then we have something we have already discussed, like we have different stimulus. Someone has told we can reuse the things. So we have different sequences which are independent sequences. So these sequences we can reuse. So all these come under the features of the UVM basically. Now, the same thing, like we have the modularity and reusability. By now, everyone would have got an idea like why exactly we use UVM is basically more on its modularity and reusability. Modularity, it means that they are designed as a modular components, different components, driver, monitor, sequence, sequencer, test bench, like that. We have modularized them. So that's why we are calling it as modularity. As it is module in the form of modules, we are able to reuse them. So this is the first thing which has to come to your mind to anyone of you when someone asks why we are using UVM over the other SystemVerilog. We already had some mechanism, but why we are using this methodology of UVM? So anyone asking you that way, you should be able to tell this. This is the basic thing, like anyone will ask you from the UVM. So by the time you complete your workshop, you will have more idea. But for now, at least you should know like what exactly are the different features of UVM. So you guys can just go through this. Like we have already discussed, right? It can be, we have something called randomization. We can just layer the sequences. Means we can have one base sequence and then we can have one more sequence. Base sequence is basically you will put all the common data in that base sequence, and you can have multiple other sequences which will be extended from that base sequence. The new sequences will have only the functionality related to that particular test case, but anything that you are using in common with all the sequences, that will be present in the base sequence. So when you do that way, it is easy for anyone to understand, okay, these are the common things for the different sequences. So we are trying to inherit the particular sequence from the base sequence, and then you are trying to do your particular test behavior, whatever you are trying to do, that particular stimulus you will give in that particular sequence. Okay. And then we have also UVM factory.
Hello.
So yeah.
Ma'am, what is the mean by modular component?
Modular component is nothing but there is nothing like modular component. It's like what they're trying to say is we have different components like UVM driver, UVM sequencer, UVM agent, like that we have different components. So each component we are just separating them, right? Just we are creating each module type. Like how the entire workshop, 15 days workshop is differentiated by like day one will be having this, day two will be having this. So it's easy for you to now entire workshop is done, and then somewhere after some 2-3 months you want to come and discuss, then it's easy for you to see the day wise content and just click that recording instead of seeing the entire content. It's better to see this way, right? Like day one content, like that. So we have different components. So UVM driver means it has some functionality. So in UVM driver only those things will be there. In UVM agent means there is one functionality. Like that, it is basically made in different modules. That's what they're trying to say. It's a modular component. But as name such, there is nothing like modular component. There is no such component in our test bench. Just they are trying to explain you in that way. Is it clear?
So in SystemVerilog, in
Hmm.
all driver sequencer, like not sequencer, generator, all are in one module, right? But here each are in different.
No. That also, like you have generator driver like that, right? But there is no something like hierarchy, like a UVM hierarchy. You don't have some base classes from there. There also you have generator driver in a different thing only. But here you have something like base classes, all that. You have something like UVM factory where you will register each component there. So based on that, you can just override a particular component or UVM driver or something. You can just override it, which you cannot do that in the SystemVerilog. This is because of the UVM methodology. Whatever features it has, is making us easy to change it from the just top level. So these are the main benefits of using the UVM.
Okay.
Yeah. So then we have something like UVM factory. Basically, the UVM factory is nothing but each component which we are trying to like UVM driver, all this there, right? UVM sequence, everything. So if it is a component, you have to use some factory registration macro which is related to the component. And if it is in sequence or if it is belong to the UVM object thing, then you have to use the UVM object specific macro to register that particular what is that UVM sequence or anything. Okay, so this is nothing but UVM factory. We will go through regarding the UVM factory also further. So just UVM callback is also some advanced concept. So right now I will not try to put that into your minds. So just go through what is UVM factory and UVM verbosity through whatever is written over here. And then when we go to the further sessions, you will get an idea. And UVM verbosity and severity we have already discussed, right? So basically these are the parameters which give us the control over the report mechanism, whatever we have reporting things, those things which are reflected in the log. Based on that you are taking a control. So severity is different from the UVM verbosity. So the severity means like UVM info means just you want to try to print the information, you want to just give the like driver is started, like that. There is something called UVM error. The name itself it says that like the UVM error means if there is some false condition, then you can print the UVM error message saying that this is. So based on that you will understand, okay, here based on the report what you will get, the reports will be like how many number of errors are there, how many number of infos are there. Infos we will not worry about because they are passing, that's why it's in the info state, right? And the errors means you have to look at why is this error encountering, what is the thing that made it error to encounter. All this you have to do an analysis and debug it. And then it is comes to the UVM fatal. So the severity is the name itself it's saying, right? Like is it normal or is it something very unusual? So fatal means which is nothing but very thing like the component itself is not there. and you are trying to use that, so it is fatal, right? So whether it is not get created itself, there is some issues like that. Very something very severe will be included in the UVM fatal. For example, you have randomized, the randomization itself failed. That is something severe, right? Because without randomization itself, how you will go through the next process? Like when the input is only not there, how you will put that into the different analysis or whatever thing? So those are some of the things which you can include in the UVM fatal. So the something like UVM warning, like how we have in a Verilog, we have something like warnings, right? In the same way, we have UVM warning, which can be we have to just have a look what is it talking about. If it is ignorable, you can just ignore it. Otherwise, if you feel it is serious and you want to cover it, then you can also resolve those errors. But main things are the UVM error and UVM fatal, which you have to put more focus and to figure out like what are the things that has gone wrong, and you have to work work towards it, and then make sure that every errors and the fatal are getting cleared. Okay, so this is all about the UVM verbosity and the UVM severity. So this verbosity will be attached to this different severity messages what we write for UVM info. For suppose for that we write some UVM verbosity low, medium, high. However, while coding we can just discuss those, and there is some priority list also, like the UVM high has more priority or low has more priority, like that it is there. But by default it is UVM medium which it is taken. If you haven't mentioned anything from your side, it means that it will take the UVM medium. Okay. So in the process of the explanation of the theory concepts and whatever coding, every day if there, I feel for today there is nothing much interview question that could come for this today's topic. It will be like, why do we need UVM methodology basically? Because today we haven't discussed anything in detail. Now we have just discussed only the intro part of the UVM and how exactly UVM works and what are the major features we have over the UVM, all this. So I'll include interview questions also in the workshop. So you guys can go through and can get back to me. And after some 2 to 3 sessions, I'll also provide the assignment questions for UVM, which you have to work and you have to get back to me with the assignments. So it will be easy for you to evaluate your understanding over the sessions. And if you are not getting it, then we can work on those assignments as well in the session. So you guys can just go through. This will be nothing but the summarization of whatever we have gone through now. Like what are the things there in the UVM, though that will be only replicated here in a structured way. So to explain someone, it will be easy for you. So that's why I have put everything in one slide and I've written here. So now my question is, what is the difference between the UVM test bench and Verilog test bench? Even in Verilog we had a test bench, and SystemVerilog also we have a test bench. So what is the difference between these two? Can anyone tell me?
So the major difference between Verilog test bench and UVM test bench is the class-based stimulus that we give.
Yes,
So
correct.
Verilog doesn't support object-oriented programming, but the SystemVerilog and UVM have this feature. So this main purpose is for the reusability and the ability to cover as many features as we can of the DoD. From the Verilog, we can just directly provide the stimulus, but that will be very hectic for a complex design. We cannot provide, so suppose we have a multi-bit 23, 24 bits variable, and we cannot provide those values from those combinations from the Verilog test bench. But using the random and coverage driven property of the UVM, we can randomize and constraint wise we can provide the stimulus to the DoD in an easy way. That is the main thing.
Yeah, that's true. So we have the test bench even the Verilog also, SystemVerilog also, UVM also. UVM is just methodology, but the programming language which we use is nothing but a SystemVerilog. The SystemVerilog is nothing but an object-oriented programming languages, like how we have C++, all this, right? In the same way, SystemVerilog. Or over the C++, we have different other features which are been embedded in the SystemVerilog, which makes it more interesting regarding like has how Ankit mentioned, like randomization. So you can't sit and give the each and every stimulus by just hard coding through the test bench, right? In the Verilog, how we would give. Those are the simple designs. That's why it is working that way. But in the real-time project, it won't be that simple for us. So for that, we have something like randomization, all this, right? So this is the major difference is like from the regular test bench and the UVM test bench is like we have a class-based environment here where in the Verilog we don't have such, okay? So can anyone tell me what is the difference between the static component and the dynamic component? I would like to hear from you guys because most of the people are aware of SystemVerilog, I have heard. So anyone should know like what is the difference between a static entity and a dynamic entity. So class is a dynamic
Yeah,
entity or a static
I will.
entity? Yes.
Class is dynamic thing. Whenever we will
Okay.
call the function, it will come and execute and go. Static is nothing but when it is configured, it will throughout it will stay to the run phases. It will be present. That is mean by static. So when you do configuration, everything that will be a static. The function called UVM base, that everything, the functioning call, everything will be in the dynamic thing. The task run phases, everything will be in the dynamic.
Okay. Okay.
Yeah.
So class is a standalone. Standalone
No.
in nature. Okay. So what do you do in case if it is not standalone in nature? How do we support it to run? What is the thing you do it? Fine, no problem.
Yeah.
So here I have written like this is nothing, no one will ask you like an interview question, but it is very basic for us to know, to understand practically like how things work. Like what is the difference between, most of the people have worked on so many projects, they'll say that I have worked on this project, I have worked on this project, but they don't know what is the basic difference between the static and dynamic entity. So module can be called as a static component or a static entity.
Yes, module is called as static.
Yeah. So class is a dynamic entity.
Class
You have
is a
already
dynamic
told.
entity. Yeah.
Yeah. So you can just go through this, like what is the basic difference between the static and dynamic. Like like we know like a class is a dynamic entity. We will create an object for it, and when we create the object for it, we construct it using some new or something, right? In the same way, in the UVM, each component, when I'm telling you, we have something like UVM driver, we have something like UVM monitor. So that component has to be created. So there is something called create method in the UVM. To just create the component, we have something called create method, and we have different phases also in the UVM. So what phases means nothing but, so now we have some for what we can say. Huh. Like for an example, we have a meeting, like Zoom meeting, we have it. So we have decided like it will be at 7 p.m. or something. So there will be some communication between us, right? Like there will be phases also in the UVM. Like the one, for example, only if I join as a host, first if I join, then only you guys can join further, right? Even in the same way, in the UVM also, we have different phases. Like first the build phase has to be done, then the connect phase has to be done, then the run phase has to be done. So the things which are has to be executed are synchronized using phases. So we have divided each each functionality into the different phases. So in build phase is nothing but first what when the host enters, then only the participants can enter. In the same way, in the build phase, when the components are created, then only we can operate on those particular components. So first the components are created, then the components are connected using the connect phase, and then the operations, whatever sequence, body, all this run in the run phase. So these are nothing but the different phases in the UVM. This is also which is new in the UVM, which was not there in the SystemVerilog, right? So in the UVM we have all this. So that is all about the different UVM phases. We have a detailed session about the UVM phases also in our coming sessions. I think it should be in the day 2, I guess. So we will discuss like what are the different UVM phases we have. So here why we entered into the we have something like dynamic entity and static entity, right? So here the dynamic entity, we have to create an instance of it, and then we have to create it using the new object. So when we are creating it, so if we just delocate it by using it some null, or we have to put into the garbage, then only it will get deallocated. So those things which are there that I have just mentioned over here, you guys just go through it. If still you guys are not understanding it, then let me know. We will work on that, okay? And then I thought, let me share you one small code, like how we will make this, as I have asked like whether the class is standalone or not. So she said no. Then how do we make it work? It's like we can have to use a module where we have to create the object, and we have to do it, and then inside the initial begin and whatever properties you are for that particular class. If there is some task, if there is some function, you want to use that particular task or function, how will you use? Inside the module, you have to create the instance of the particular class where your task or function is there. So that particular function you can use through that particular instance. Let me show you one oops code which I have, so that you guys will get some idea. So this is my one of the class, like I have some class A. So here I have taken different, so what do you mean by properties? These are the different properties of this class, okay? So here I am using some function new. This is my function. So this is nothing but your method. So each class will have some properties and will have some methods, right? So I have one more method called function print. So this is what is there in my class. It is ended with class. So enclosed with class and end class, how we have module and end module in Verilog. In the same way, in the SystemVerilog language, we have something like class and end class, which has all these things. And inside the module, what I said first, our class has to be created its object, right? So we have just write A and then AH. This is the instance of it, means the handle of it. Inside the initial begin end block, we are creating it, and then we are trying to print it. So whatever things, whatever properties you want to use of this class, you have to use with this particular handle itself. So handle dot, you will use that particular thing, and then you will try to print it. Okay, so this is to get the overview, like how you are making which the class is a dynamic entity, module is a static entity, which you are trying to instantiate inside the module and trying to make it standalone. Because what is standalone means the class itself cannot be run. So we need something like module which is a standalone, and you have to put that class inside the module, and not entire class, means a particular class it's an instance, and then you create it inside the module, and then you can access the different properties and the different methods of that particular class. So this is what I meant, how do you make it standalone? Okay, so let's go back to our session. So next we have something called UVM Testbench hierarchy, right? So as I already told, like we will be building the component from one component to the other component like that. So here we have something like we already discussed, like we have different components in our testbench architecture. So each component you guys will get familiar while working with the different codes and all. So for now, let's have, but before that, everyone should know, right? Like how our testbench architecture looks and all. What is the hierarchy? So can anyone tell what is the topmost class we have in the UVM testbench architecture?
TB.
Yeah, so the test, right, basically?
Yes.
Yeah, so what are the different functionalities which we perform in the test class? What are the things we can do?
There we will connect the sequence, different TLM ports and sequencer handles everything. Then we will run the test cases.
Okay. If you see the architecture, you guys will get an idea from where to the where, what are the things are connected.
We
But
will
for
connect
now,
diver,
yeah.
monitor every classes, and we will create instance, and we will make the port connection there. All the diver, monitor and monitor to coverage all the ports connection. Then we will run the test cases there.
Yeah, correct. So in the test bench, basically what is trying to say is from the test bench only the test case will be getting starting to the run the test case. There is something called initial block where inside that we have something called run test keyword. Inside that you will give a particular test case which you want to run. This is if you don't provide anything, then from the command line argument, if you are not providing anything, then it will take from that run test argument whatever test case you are providing. No, that particular test case will get run. If you are providing from the command line argument, then that test case only will get run. Okay. So when you provide from the outside means a command line argument. So now in the run test argument, that will be just overridden with by the test case which you are providing from the command line argument. So for now, I think now it will be confusing for you when I tell like that. But when we see the code, you will understand. For now, what you can have an idea is that from the test class, what we will do is we can configure our test bench. Basically, if you want to pass any of your virtual interface from the test to the driver, or you want to pass any of the interface to the monitor. So all those things you can do in the test itself, test class. You can have a config DB where you will set the things and that particular component, which is the component which is trying to receive that particular thing like interface or whatever is there, that should have the get method. So basically you are like how we have in the SystemVerilog mailbox, right? You are putting the data from which component. The other component which is trying to collect it will have the get method, like in the same way, in the config DB, we have such thing. So as I said, the run test will be there, then only the hierarchy, the root component it has to be created. Like I said now, so like when the host is not there, the other participants cannot join. In the same way, the test, the root name has to be created, and then the subsequent lower component gets created. So what we can say is that this is the stage in the test class where it creates the root component. So that we can say that is one of the functionality of the test class. And the other thing is what we can say is like what you said, we connect, right? Like inside the test bench test architecture, when you observe, there are the different TLM ports which we connect from one component to the other component. So any connections that are lying under the test, no? So all those things will be connected in the test. So basically the sequence to the sequencer connection, whatever is there, using some start method, we do it. So that particular sequence to sequencer, that connection you can observe in the test class. So these are the main functionalities that you will be observing in the test class. So now the question is, you are telling the test class is there, everything is there. So is there any base class for this particular test class? Like we have discussed now, for everything, for
every component there is a base class.
So for test, do we have any base class or we don't have it?
Yeah,
UVM test.
Yeah, correct. So like how for the driver it is UVM driver, in the same way for the test we have a UVM test. So whenever a particular test in your environment, that has to be extended from the UVM test. Okay, so this UVM Testbench Architecture, as we were telling that we can reuse this many sequences, and there are different kinds of reusability. That is, you can say that horizontal reuse means if you are using the same components in the different projects, we will say it as a horizontal reuse. And if you are doing in the same project in the other hierarchy, so vertical in the sense like it is following a hierarchy, right? Means like usually hierarchy means it's a top to down, like or down like that. So that's why you will call that kind of reuse as a vertical reuse. And so basically that's different two types of different reuse things. And the other things are like we have in the test again we'll be inside test you will be having env, inside env you will be having agent. So when inside test we have env, you have to create that particular env inside the test also, right? So you have to declare that handle, and whatever is declared and whatever is there, you have to create it. So these things we will see through the code. So now just don't panic like what is it, it's confusing to me, but just have an idea. Like when we are trying to code, you should be like, okay, I have heard something like that on the session that day. So that's why this I'm observing in the code today. So to just have that connectivity, I'm just trying to put some information in your head. But that's fine if you don't understand also for today.
Hello, ma'am.
So this is how the,
Can you go to previous slide?
Yes.
So I want to ask about this test class. So is this a class or like it is enclosed in module and end module? So
No.
that
Uh,
we are
yeah.
instantiating the DUT and the very virtual interface setting for the config DB and run test that is there. So we are doing inside the module and end module because that is a static component.
Yeah, correct.
So
The top module will be having one thing. The other thing is the test class will be having, where we will have the, like in the top module itself, we can have the initial block which is there, like the run test, everything will be there in the static
yeah,
component
in
actually.
class we cannot
Inside.
use initial
No,
definition, right?
no, we
Okay.
cannot. Yeah.
Okay.
Yes. So that's why when we go through the code, it will be clear. But that's okay if I've asked that out. It should be because you already
Okay.
have some idea. That's why you are asking, right? That's
Yeah, I
okay.
got confused actually. That's why I asked this.
That's okay. Okay. So the UVM testbench hierarchy will look like this basically. So first you will have the test. So what you have asked, no, inside this test also will be there in the top module. So this entire thing, this test, whatever is there, which will be having in the verification environment. So however, as I said, it's all a dynamic entity. So now the test class is there, means it's a dynamic entity, right? So it cannot run its alone. So we will be having a top module, end module, which will be, for suppose you have declared this as top, there you will instantiate any of the, like watch, if you will be using some interface, that interface things you will use, the connections, whatever is that you will do in the top module. And even you, if you want to set the config TP, that also you can do in the top module itself. And then whatever the run test will be there, that will be inside the initial begin, which we cannot use in the class, right? It will be used in the module itself. When I showed you the code here also, here, if you see the code also, you didn't write this initial begin block inside the class. You have written inside a module, right? So inside the initial begin and you are using this class and its instance. So likewise also the same, even in the test bench also. So all these things you will write in a top module, the run test, everything. And anything you want to set related to verbosity also, you can write like cert verbosity, that are little advanced things, which if you don't know also, that is fine. Okay. So then, so now let's not deviate and let's focus on this. What is the test bench hierarchy looks like? So we'll have something like test. Inside that we'll be having ENV. Inside that we have agent. Inside that we have driver, monitor, sequencer, driver, monitor, sequencer. Okay, so you can have multiple number of agents, agent 0, agent 1. Actually, the arrow should be in a reverse order. I don't know why it is.
Excuse me.
Yeah.
Yeah, like in UVM, we don't have generator.
No, we don't have generator. Instead of generator, here we have something called sequence. So what generator does in the SystemVerilog, no? The same thing will be done by the sequence over here. Basically, whatever things you want to send it to the generator to driver, we will send it over there, right? Here the sequence will be there. Sequence to the driver will be sent, but sequencer is in between the sequence and the driver. So there is some important concept called sequence driver handshake. So that we have to go through to understand how the things work here. And that is the most important question people will ask you regarding the UVM. If you know that, if you say that I know UVM, so you should be knowing what is that handshake, how it works. So everyone will ask you that. So we will discuss that further, but we don't have a generator in the UVM.
Yeah, like also in one of the slide, like you mentioned sequence and sequence item. Is there any difference or like?
Yeah, basically, whatever sequence is nothing but we also have a transaction class, right? Where in the transaction class itself, we give us different whatever input ports we have, for example, and some address is there, some data is there. You have randomized that address and data. So that is one transaction class. So these address and data are nothing but the transaction items. Okay, so these things which we have in the transaction class, that will be sent to the sequence, and the sequence whatever it is sending to the driver, no, that is nothing but the sequence item. Basically, whatever transaction that is moving from one component to the other component are nothing but the sequence item. So the transaction class will be extended from the UVM sequence item base class, like how driver is getting extended from the UVM driver. In the same way, the transaction class will be extended from the UVM sequence item. Okay.
Okay, so like transaction in S3 is equal to the sequence item in UVM.
Correct.
Okay, got it.
Then anyone else have any queries?
Even we will be adding the scoreboard and coverage in the test bench, right? In the environment, this thing.
Yeah.
There it is not written the scoreboard and the coverage thing.
Actually, the coverage, we already had a workshop before where we had detailed things about the coverage. So mostly we will not be covering the coverage, but for scoreboard, we have mentioned like how the scoreboard coding is done. Okay. So that thing we will go through. Actually, the UVM is very big concept. The workshop which we have done to cover everything is actually impressible, if I would say, for this much cost, because nowhere you would find something related to UVM in this much less cost. Just in a motto to help the students, we have launched this workshop. So we will try to cover as much as possible in the workshop. But if you want in detail, then we can discuss further. Okay. But I will try my best to cover whatever is mentioned, at least in the curriculum. Okay. Yeah. Others, any queries?
Yeah, like so you told like it's difficult to cover many items, right? So if you feel any important concepts that is not covering in the classes, maybe you can mention, right? We'll refer like when we have time.
Yeah. See, basically, whatever is mentioned in curriculum, I will cover all those. Anything other than that, like coverage, as she asked, we haven't mentioned about coverage in the workshop, right? So we will not be able to cover that like that.
So is there any other, like you mentioned, other course is there? So that is, okay. So if I enroll for that, I can get information on coverage as well there?
Yes, everything.
Okay.
You can customize your course as you need. Like, if you want to work on particular protocol, you can also. And if you want to do the SystemVerilog, some are not well aware of the SystemVerilog programming languages and the interview preparation, interview questions, or any of the practical coding you are not confident. So for everything, we have the course. You can customize in your own way for the particular student, and we can do it.
Okay, thanks.
Yeah. Anyone else have any queries? So far, whatever we have discussed in today's session, is it understandable? Are you able to get what I'm trying to say, or is it fast? If this way we continue in our next sessions, is it okay?
Yeah, it is okay.
Okay. What about others?
Ma'am, for me it is fast.
Okay, fine. So, but still today you have understood, right? Whatever is covered so far.
Ma'am, I didn't understand completely, but I got
some overview of it.
Yeah.
Yeah, I feel so, because if I don't know anything about UVM and I am joining the same session, I think I would be the same feedback I would have given like Divyani. Like, I just got something, but I'm not getting the 100%, but I feel like, okay, I have understood what is there, because we are just imagining it, right? We haven't seen anything in the code part. So that's why it feels like that. So that's fair enough to have that kind of feedback. So don't worry.
And one more thing, classes will be there on Sunday and Saturday, right?
If there is anything, I will inform you upfront. But mostly thinking to it will happen. Mostly this Saturday, I think it won't be there. I'll inform you guys in the group.
Okay.
Yeah, so the timing is comfortable, right? The 7 p.m. for everyone.
Yes.
Yeah, from 7 to till what time?
Actually, it depends. So today, it's an intro, but sometimes if it is little complex thing, maybe we might extend. But I'll make sure that it will be somewhere around 7 to 8:30, not more than that.
Okay.
Yeah. So today, due to some technical glitch, we had to connect at 7:30, but usually it won't happen that way. I'll make sure that we'll connect at 7. And whatever recordings are there, right? The day-wise, I will share the recordings, but the presentations and all will not be shared to you guys. You guys can make a note of it from the presentations, or while some of the things through the on the flow. Also, you guys can. If there is anything, something you have to exercise at your own end or any assignments, those things I will share it. But the PPTs and all, it's not. We won't share, but the recordings we will share it to you guys. Is that clear for everyone?
Yeah, okay.
Okay, ma'am.
Yeah. And someone has asked something like reference documents. If I find any good documents, I will share it with you. We have already shared some videos on UVM also. Those things also guys go through before coming to the session. What will happen is you will be already having some information. This will be some repetition, so you will remember it well. So if you are not understanding those sessions, it is not comfortable to you, then leave it. That's not a problem. But if you have time, then you guys can go through all those. Okay, guys, then we can end the session for today. And let's meet at tomorrow at the same 7 p.m. Okay.